Hello, this is a review of the metric system. This is by Ashley, Leslie, and Yura. So, to begin, we will be going over 7 topics like what it is, why we use it, some common applications, some common units of measurement, example, conversion problems, unit conversions, dimensional analysis, and some examples. So this is how the metric system looks, and as you can see, there are a lot of prefixes, symbols, and multipliers that are included in the metric system. Also, you should already notice a common trend being that all the multipliers are a factor of 10, and we will explain later how that can help you. To begin, the metric system is a standard way of measuring and expressing quantities. The International System of Units is a system of measurement based on the metric system, and these systems are based on a decimal system that uses base units with prefixes to denote multiples and fractions of those base units. So for the example here, we see that the unit in the middle is meters. This is our base unit and it increases or decreases by factors of 10. These new units are expressed with new prefixes like kilo or milli. Now, why do we use the metric system? Well, we use it because it ensures consistent and unambiguous measurements, allowing for easy comparison and replication of experiments. Also, the decimal based nature of the metric systems makes conversions between different units, like meters to centimeters, relatively simple. This just means that the multiplier being factors of 10 makes conversions easier. And now, common applications of the metric system, are usually found in science and engineering, medicine, and everyday life. In science and engineering, it is common to use a metric system in experiments and calculations. In medicine, it is common to use it for dosages and body measurements, and then especially if conversions are needed. And lastly, in everyday life, it is used in road signs, beverages, and food. Hence, overall, the metric system is a part of everyone's life because it is used everywhere in the world. Some common units of measurement in chemistry include meter for length, kilogram for mass, Kelvin and Celsius for temperature, seconds for time, and moles for amount of a substance. All of these can be expressed with new prefixes as long as you convert the units using the methods we'll describe next. A very helpful mnemonic for the metric system is King Hector died unexpectedly drinking chocolate milk Monday night peacefully. As you can see, each word corresponds to a prefix. For instance, king is used to help remember kilo, and died is used to help remember deca. Now, the last 3 words of the mnemonic are not commonly used since micro, nano, and pico are not used to a great extent, but it is helpful to memorize them in case it does appear anywhere. Please note that the base units are meter, grams, and liters. These are the base units that you should memorize as they will appear in the AP exam and they are fundamental to solving problems. An example of how grams would look if it was converted to all prefixes is shown. Please note the symbols like the K in front of G because these are the symbols that you will be using in your problems later on. Now, exponentials. This is to take a better look at the relationship between each one. Since they are a factor of 10 and go in order, it is very easy to move between units since you just need to move the decimal to convert from one to another. Please note that micro, nano, and pico are jumping from 6, 9, and 12 instead of 4, 5, and 6. If you have a problem, you just should really check to make sure if it's micro, nano, and pico that you are not making a mistake and putting like 4, 5, or 6. Now, this is a list of the prefixes that correspond to each prefix. Make sure to not confuse deca and decis and put the symbol as D as only deci is D, since deca is da. This can make your answer wrong if you make a mistake on the symbol. Now, the question is asking to convert 12 kilograms to grams. So we write down what the question gives us, and since we already wrote down the mnemonic, we can move on and identify where the decimal point is. This is where the decimal point would be, and this is the decimal point we will be moving. Okay, look at the mnemonic below. Since we started in kilograms, we move the decimal point 3 times to the right, since that is how much it takes to get to grams. This is what you would also do to the decimal point for 12. So as you can see, there are green arrows on the 12, signifying that it's moving to the right 3 times, like how we did with the mnemonic. Now that we have done that, we get our new value with the decimal point all the way to the right. which means that 12 kilograms is equal to 12,000 grams. Now, this is a longer problem, but you should pay attention to what you are given and what you are being asked to find. The question says, a particular experiment for science requires 120 millimeters of a solution. This science teacher knows that he will need to make enough solutions for 40 experiments to be performed throughout the day. How many liters of solution should he prepare? Okay, so first we should list the known and unknown quantities. What we know is that one experiment requires 120 millimeters and 1 liter is equal to 1,000 millimeters. And now what we don't know is how many millimeters would be needed to make 4 experiments. In order to find this, we multiply 120 millimeters by 40 since that's the amount of experiments that we are going to be doing to get 4,800 millimeters of solution needed. Now, the second step to solving this type of problem is to calculate. You already given 4,800 millimeters of solution that should be used. Now you need to convert this to liters. You can pause the video to solve on your own. So now that you have paused and solved, you should have gotten 4.8 liters. And in case you didn't, this is how to solve it. So the first thing you should have done is identify where the decimal point is. And it's at the very end of 4,800. Now, the second thing you should have done was move the decimal point until you got to the unit liters. Remember, the mnemonic can help you with this. And this is how the mnemonic could have helped you. As you can see, we start millimeters, or as would be represented with M, and we move the decimal point until we get to the base unit, which would be the underscore, since we need to get to liters, which is the base unit. And hence, you should have gotten 4.8, which would have been 48 liters with significant figures. Do not forget your sig figs. Now, there is another way, and this is kind of a lengthier way to do it, but it is useful to familiarize yourself with this in case you ever need it. So the other way involves multiplying by knowing that 1 liter is equal to 1,000 millimeters. We multiply by 1 liter divided by 1,000 millimeters, and then we cancel out the variables that are the same, or that cancel out, and we are left with liters. And when multiplied, we get 4.8 liters. Now, for this example, they are asking you to convert from 12.5 grams to kilograms. So our given number is 12.5 grams, and we want kilograms. We also know that 1 kilogram is equal to 1,000 grams, because if you use the King Hector died mnemonic, we move the decimal 3 times to the right. Therefore, 1 kilogram is equal to 1,000 grams. So we have 2 possible conversion factors. Now you can try to set up the problem and solve it. First, we begin with the given 12.5 grams. Using this value, we figure out which conversion factor will be needed. And we use this one because we need grams to be on the bottom so that it cancels out and leaves us with kilograms. After we divide 12.5 by 1,000, we get 0.0125. We need to also keep sig figs in mind, so we keep 3 sig figs because the given problem also has 3 sig figs.
Now, dimensional analysis is a problem-solving technique that uses conversion factors to convert between different units of measurement. It's very similar to the unit conversion, but for dimensional analysis, we are actually changing base units. So we change from pounds to ounces, meters to inches, and so on. One way to do this is to draw a railroad as seen here in either ways. Both will work. Please note that the top is multiplied, then this is divided by the bottom. For dimensional analysis, you will most often be given a conversion factor, so just take a look and keep them in mind. The problem reads, the mass of a competition frisbee is 1 to 5 grams. Convert its mass to ounces using the unit conversion factor derived from the relationship 1 ounce is equal to 28.349 grams. In order to get 2 ounces, we begin with 1 to 5 grams and multiply it by our unit conversion factor. Our unit conversion factor can be one of these two. And remember, we use the one that will cross out our units. So, to set it up, it will look like this. X amount of ounces is equal to our given value times 1 ounce over 28.349 grams. So we multiply the top, which equal 125 times 1, then we divide this value by 28.349 grams. You should end up getting 4.41 ounces. Remember, we have to keep in mind the significant figures. So our problem only has 3, as in 125. So we use 3 in our answer. Now you should try this problem. Given that 1 liter is equal to 1.0567 quarts and 1 quart is equal to 32 ounces. You might notice that these two conversion factors are not the same. This is because you may need to change units more than once to obtain the desired unit. So, just a hint, you'll be using both. So you'll have two steps in your problem, not just one like in the prior example. Okay, so your setup should look like this. 1 ounce is equal to 1 quart over 32 ounces times 1 liter over 1.0567 quarts. The ounces will cross out, the quarts will cross out, and this will leave you with liters. Try to calculate it now. You should have gotten 0.02957 liters. And remember, it's important to consider significant figures. There are 4 in our problem, so our answer should have 4 as well.
Okay, so now try these on your own. These are for comprehension purposes, and if you do well, then that means you understood it perfectly.
Thank you, and good luck in camp.